Welcome back to the deep dive. Today, I want to start by addressing a very specific feeling.
Oh, I think I know where this is going.
Right, it's that 3.0 a.m. feeling. You're lying awake, staring at the ceiling, and you're thinking about your kid. They're 4, maybe 5 years old.
The pre-primary foundation age.
Exactly. And you're thinking, they played with Legos for 3 hours today. They chased the dog. They made a mud pie. But did they learn anything?
It's the universal school readiness panic.
It is a panic because we see other kids or we hear about these programs and we think, shouldn't they be sitting at a table? Shouldn't they be tracing the letter A over and over again?
The fear is, if they're just playing, am I failing them?
Yes.
And it's probably the single most common anxiety we see in early education.
Hmm.
And honestly, it's where a parent's gut instinct clashes with what we think school is supposed to look like.
So that's what we're tackling today.
That's the plan. For this deep dive, we've pulled together a stack of sources that, they really try to bridge that gap. We've got the strict government standards, the Western Australian and V9 Australian curriculum,
Okay, so the official rules.
the official rules, and we've paired them with a pretty heavy-hitting clinical report from the American Academy of Pediatrics on the neuroscience of play.
So we have the bureaucracy on one side and the hard biology on the other.
That's the mix. And our mission today is to show you that these two things, they aren't fighting each other. In fact, when you look closely, play-based learning isn't just fun. It's actually the most rigorous, scientifically backed way to hit those government targets.
Now, that is a massive claim because I think most of us see play and curriculum as like total opposites.
Enemies, even.
Yeah, you stop playing so you can get to the real work, the curriculum.
That's the big misconception, and this is the first major aha moment from the source material. The curriculum describes outcomes. It tells you what child needs to know.
Okay.
It does not tell you how they have to learn it.
Wait, so the government documents don't actually say, sit the child at a desk and make them fill out a worksheet?
Not once. Nowhere in the foundation or pre-primary guidance does it say a child must learn by sitting still. The requirement might be, say, connect number names to quantities. That's the outcome.
Right.
Whether they do that with a worksheet or by counting how many rocks they can fit in a dump truck, that's the method. And the science is very clear that the method matters a lot.
Okay, so if the method is up for grabs, let's talk about why the sources are so focused on play. Because I'll be honest, sometimes play just looks like chaos.
It can look like that, for
It
sure.
looks like they're just blowing off steam. But this pediatrics report you have says there's, like, actual biology happening under the surface.
It is serious biology. I mean, the report gets right into the neuroscience of a developing brain. At this age, a child's brain is it's frantically building its executive functions.
So that's things like attention, memory, controlling your impulses.
All of that. And the report highlights this one specific protein. It's got a bit of a mouthful of a name, BDNF.
I saw that in the notes. Okay, give us the explain like I'm 5 on BDNF.
Think of BDNF, brain-derived neurotrophic factor, as fertilizer for your brain cells.
Fertilizer. Okay, I get that.
When a child is really deeply engaged in play, their brain releases this protein, especially in the amygdala and the frontal cortex. It helps neurons grow and basically builds better connections.
So play isn't just messing around. It's a chemical trigger for brain growth.
It is literally infrastructure building.
Yeah.
And if you want to know how powerful this is, you have to look at the rat study they mentioned in the report.
I was hoping we'd get to the rats. This was my favorite part of the reading.
It's just fascinating stuff. So researchers, they looked at young rats doing rough and tumble play, wrestling, chasing, that kind of thing.
Right.
And they found that when the rats played, they made this specific high-pitched chirping sound. They actually call it rat laughter.
Which is just a great mental image. Bunch of giggling rats.
It is. But here's the kicker. The rats that did more of this laughing play, they actually refined the physical structure of their prefrontal cortex.
So part of the brain for decision-making and social stuff.
Exactly. The play-deprived rats, their brains were physically less mature. They had real trouble with social situations and solving problems later on.
So the laughing rats were actually building a better, more flexible brain for their future.
A social brain. And that brings us right back to humans. If a parent is thinking school readiness means sitting still, the sources are basically screaming that that's a misunderstanding of what readiness even is.
Because if you force them to sit still too early, you might be skipping the rat laughter stage.
You're skipping the BDNF stage. All the data shows that long-term success isn't about who writes the letter A first. It's predicted by social skills, emotional regulation,
Can you handle frustration? Can you ask for what you need?
Exactly. And you don't learn to handle frustration by getting a gold star on a worksheet.
No, you learn it when the tower you've been building for 20 minutes falls over.
And you feel that flash of anger, and then you decide to try again. That's the learning. The sources really emphasize that for this age group, information only sticks if it's connected to active engagement and emotional meaning. If the child isn't interested, the connections just don't form.
The interest factor.
Yeah. But, okay, let me play devil's advocate for a second. We get it, play is good brain fertilizer. But we also have to make sure they learn the hard stuff, math, science. We can't just let them run wild in the backyard and hope they stumble into algebra.
No, you're absolutely right. Feral is not a curriculum strategy.
Ah, right.
And this is where we have to introduce a really specific term from the research, guided play.
Guided play. So how is that different from just regular play?
This is the sweet spot. It's all over the age-appropriate pedagogy's sources. It sits right in the middle. It's not free play, which is the feral running.
Right.
And it's not direct instruction, which is the adult standing at the front lecturing.
So what's the formula? How do you do it? Well, the formula is,
Hmm.
it's simple in theory, but it takes some skill. The child leads the activity, but the adult scaffolds the learning.
Scaffolds.
The source material uses this great phrase for it, constrained tinkering.
Constrained tinkering. I like that. Unpack it for me.
It just means you, as the parent or educator, you shape the environment. You might set out some specific blocks or a magnifying glass and some leaves. You have a learning goal in your head. Maybe it's counting, maybe it's vocabulary. But you let the child discover the solution.
So you're not the teacher at the blackboard. You're more like the stage manager.
That's a great way to put it. Or a
Yeah.
sports commentator. You're watching the action, describing it, pointing things out, but you're not grabbing the ball and scoring the goal for them.
I like that. A co-pilot.
A co-pilot. Neurologically, this ties into Vygotsky's zone of proximal development. You're helping a child master a skill they couldn't quite do on their own, but without the stress of a formal lesson.
Okay, this is great, but let's make it super concrete. Constrained tinkering sounds good in theory, but on a Tuesday afternoon, what does it look like? I know we found that animal enclosure example in the sources.
Yes.
Let's walk through that one really slowly and see how it hits the actual curriculum.
Perfect. This is such a powerful example because it shows how one single interest can cover almost every subject area. So let's say your child is into animals. That's the spark.
Okay.
And they decide they want to build a home for their little toy tiger.
So step one, they grab some blocks and a plastic tiger.
Right. And a parent might just see, okay, they're playing with blocks, that's nice. But let's map it to the actual pre-primary curriculum. Start with science, biological sciences.
Okay.
To build a proper home for a tiger, the child has to think about what the tiger needs. What does it eat? Does it need water? A place to sleep?
So as the parent, you're just sitting there and you ask a simple question like, oh, where will the tiger sleep?
Exactly. And to answer that, the child has to engage with the idea that living things have basic needs. That is a core science curriculum outcome. Check.
Wow. Okay. So we've got science. And now what happens when they start building the fence?
Well, the child grabs some sticks. They hold a stick up to the tiger. And in their head, they're thinking, is this stick high enough? Is it too short?
So it doesn't jump out.
Right. That's mathematics, specifically measurement. They're comparing length and height. And then, say they put the water bowl inside the fence. And you say, ooh, good idea, putting the water inside. You are now teaching spatial language. That's geometry.
It's all just happening so naturally. And the number stuff is even more obvious, I guess.
Yeah, you just add, so how many animals are in the enclosure? They count them, 1, 2, 3. That hits the number and algebra requirement to connect number names, numerals, and quantities.
We've got science, measurement, geometry, and number. What about English? That's the one that feels like it really needs a worksheet.
Not at this age. Early years, English is so much about oral language. When your child explains to you why the fence needs to be that high, or tells you a story about how the tiger escaped,
They're practicing vocabulary, sentence structure.
reasoning, the curriculum asks them to interact with others and create short texts. A spoken story is a text.
And the sources even connected this to Haas, right? Humanities.
Yes, caring for places and people. If you just ask, does the tiger have a friend? Is it lonely? You are wading right into social and ethical learning.
I think that's the real aha moment for me. If I give my kid a worksheet on the number 4, they learn the number 4, maybe. But in this one animal project, they're doing math, science, engineering, and ethics all at the same time.
And here's the crucial part. Because they actually care about the tiger, the learning has emotional weight. The brain is lit up, that BDNF is flowing, and it sticks.
But, and this is a big, but this all relies on the parent actually being there and interacting, right? You can't just be on your phone in the corner.
That is the guided part of guided play. You have to be present. You don't have to be in charge, but you do have to be there.
So give us the script. The sources had some really practical phrases. If I'm sitting there with my little zoo builder, what do I actually say to make it a lesson without killing the fun?
Okay, so the technique is called sustained shared thinking. It's a bit of jargon, I know,
A little bit.
but it just means solving problems together. So the easiest way in is to start with a simple observation. Just say, what do you notice?
What do you notice? That seems almost too simple.
But it works because there's no wrong answer.
Yeah.
It prompts them to look closer, which is the foundation of scientific observation. Another great one is, tell me about this. Tell me about this wall you built.
Ah, so it gets them to turn their actions into words?
It forces them to structure their thoughts. And what about when they get stuck? The wall keeps falling over. Your instinct is probably to just fix it for them. Don't. That is the learning moment. Instead, you ask, I wonder how we could fix that. Or, what do you think would happen if we tried the wider blocks?
That phrase, I wonder, it feels like a key.
It is. It's magic.
Huh.
It's not a test. It's an invitation. It says, let's be curious together. By asking these questions, you are lending your adult brain, your executive function, to help them organize their thoughts. And eventually they start asking themselves those questions.
You're the training wheels for their own critical thinking.
There's exactly. You model curiosity.
Okay, I love the zoo example. I really do. But I can hear parents listening right now thinking, I do not have time to set up a tiger enclosure project every Tuesday. I have laundry. I have to cook dinner. How do we handle that time pressure?
This is where we have to just remove the guilt. The sources are so clear on this. Everyday life is the curriculum.
The shore curriculum. Give me some examples.
Okay, the grocery store.
Right?
It is a numeracy paradise. We need 3 apples. Which is heavier, the melon or the lemon? You're doing counting, comparison, money. You just hit half the math curriculum in the fruit aisle.
Cooking dinner.
Cooking is a science lab. You're changing materials from liquid to solid. That's chemistry. You're using measuring cups. That's math. Following the recipe steps. That's literacy.
Gardening.
Biological science. Needs of plants. Seasons. The key isn't creating new moments for learning. It's just noticing the learning in the moments you already have.
The sources also mentioned something about depth over coverage.
Yes, this is so important. We feel this pressure to rush through topics. Okay, we did shapes, now we have to do colors. But the research shows it's much better to revisit one interest, like that animal enclosure, over days or even weeks.
Why is that?
That repetition strengthens the neural pathways. It lets them get into more complex problems. If they want to play zoos for 3 weeks straight, great, let them. That's deep learning.
Okay, final hurdle for parents. Proof. Assessment. If there's no worksheet with a smiley face to put on the fridge, how do I know, or how does their teacher know, that they're actually learning?
In the early years, the #1 method of assessment is observation. That's it. A teacher assesses by watching and listening.
So if I see my child sorting the laundry into whites and colors,
And they say, I'm putting the dark ones here so they don't mess up the white ones.
that's data.
That is valid assessment data.
Right.
It shows sorting, classification, and reasoning. You don't need a paper trail to prove the brain is working.
That is just incredibly liberating. The proof is in the conversation, not the paperwork.
Exactly.
So let's bring this deep dive home. The mission was to see if play can really meet these strict government requirements.
And the verdict from the sources is a resounding yes. The curriculum asks for outcomes, not worksheets. And the brain science shows that play is what builds the hardware, the BDNF, the executive function, that all future learning depends on.
And we learned we don't need to be drill sergeants. We just need to be co-pilots, using phrases like, I wonder, and tell me about.
And we learned that everyday life shopping, cooking, gardening is already packed with curriculum outcomes if we just know how to look for them.
So the big takeaway really is you don't need to add learning to play. You just need to notice the learning that's already there.
That is the perfect summary. And I want to leave you with one final thought from that pediatrics report that I found it really provocative.
Okay.
It said, play is to the 21st century what work was to industrialization.
Wow. That's a heavy statement. Unpack that a bit.
Well, it means that for a long time, the school system was basically designed to create factory workers, people who could sit still, follow instructions, and do the same task over and over.
And we're not in that world anymore.
Not at all. We are moving into a future of AI and automation where that skill set is becoming less and less valuable. The machines can do the rote stuff,
So what's left for the humans?
the skills that do matter: creativity, social connection,
Yeah.
flexibility, collaborative problem solving. And where do you learn those skills?
In play.
Exclusively. You can't automate rat laughter. You can't write an algorithm for negotiating the rules of a game.
So by letting our kids play, we aren't just getting them ready for year one. We're actually getting them ready for a future we can't even predict.
We're building the brain they'll need to navigate it.
I love that. So to everyone listening, put down the worksheet. Go watch your kids play. And maybe even join in, get some of that rat laughter going for yourself. It's good for your brain, too.
Thanks for listening to The Deep Dive.
See you next time.